Hi gang, I know it says example 4, but I'm going to make it example 3. Welcome back. We're doing example 3 now, and this one's actually from your homework, so I'm going to help you with it. It's one of the more sophisticated ones, okay? So I'm just going to help you work it out so you have it. So you've got a Norman window. Which is constructed by joining a semicircle. So you've got half a circle to the top of a rectangle. Okay, so you've got a semicircle to the top of a rectangle. Find the dimensions of the window if the maximum area of the perimeter is 16 feet. Okay, so they don't have the full picture here. They tell you in your book. They tell you in your book that this side it's number 21 when you get the homework. This side is X and this side is Y, okay? So they tell you in the book that this side is X and this side is Y. Okay, so we want to find the maximum area, right? That's what they say, maximum area. So when you do your primary equation, what you're looking for is an area equation. So let's start with the rectangle part of the shape. The rectangle part of the shape, the area of that would be what? Okay, hopefully you're thinking X times Y, because that's area for this part. Now this part here, you sort of have to figure out that if this magnitude is X, and you're looking at a circle, then halfway here has to be half of X, or X over 2, right? Which means that the radius of this circle is X over 2. Now when we talk about area of a circle, okay, a full circle, area of a full circle would be pi r squared, right? But we just have half a circle. So half of a circle So 1/2 of that area is going to be half of pi r squared. Now it's a little more complicated than that because we're not going to write it in terms of r, because the distance from here to here is r. This is r. R is equivalent to X over 2. R is equivalent to X over 2. So if I plug it into this half of this area, it's going to be pi times X over 2 quantity squared. And if we just sort of simplify this, so 1/2 pi X over 2 squared is X squared over 4. So this is going to simplify to be pi X squared over 8. Okay, and that is going to end up being half of the area. I'll get it to focus one second. There we go. So pi X squared all over 8. Alright, so the rectangle and half of the area of the circle, given that the radius is X over 2. Now the secondary equation is the constraint. So that's the perimeter. So the perimeter, okay, all the way around this, not including this, okay, it's got to be 16 feet. So it has to equal to 16. That's what they're saying in the problem. So let's start with the rectangle part. You've got this side, and this side. So you've got 1x and 2y's, okay? So far we've got 1x and 2y's. Okay, that's for the rectangle part. Now we have to do the perimeter of the circle part, which we really call circumference when we talk about circle, but that's okay. So the circumference of a circle is 2 pi r. But again, we discussed that r was X over 2. So it's, oh, before we do that, we only have half of a circle, right? So it's half of the whole way around. So it's going to be pi r, right? Because it's only half of a circle. So if you divide this by 2 over 2, it becomes, right, 2 over 2, that's going to become 1. And then again, we said that r was X over 2. So this is going to be pi x over 2. So circumference is 2 pi r, but we only have half of the circumference. So if we divide that by 2, that's just pi r. And r again is x over 2. So if you multiply this is pi x over 2. So plus pi x over 2. Now when you have a fraction like that, you want to get rid of that. Because otherwise you're going to end up, when you isolate a variable, you're going to end up with a complex fraction, and that's going to be like really, really messy. So we're going to get rid of that too. So we're going to multiply everybody by 2. And that's going to get rid of that guy. Okay, now if you look at your equation here, the easiest thing to isolate and plug in is actually y. So that's what I'm going to do. I'm going to move these guys to the other side and then divide by 4. So that is me isolating that equation for y. And then I'm going to take this equation and I'm going to plug it into the primary. Alright, so this is me plugging it into the primary. So a equals to x times y, which is all this, plus pi x squared over 8. Okay, it really depends how you want to deal with this at this point. I would suggest at the very least, like, multiply this x in and bring this 4 to the front. So bring the 4 to the front, put the x in. You can do more stuff here, but I feel like I'm just going to leave it there for me. I'm going to go right to taking the derivative now. So a prime is going to equal to, the 1/4 is just a multiplier. So 32 minus 4x minus 2 pi x plus, now when you bring the 2 down, it's going to reduce with the 8. So it's going to be pi x over 4. Okay, if this video gets too long for this one problem, I will pick it up in a second one. Alright, that is a derivative. We have to solve for the critical numbers now, so we're going to have to fiddle with this. I'm just trying to think what is the best way to fiddle with this. We've got to get the x by itself, and okay, so we've got to set this equal to 0. So you have 1/4, 32 minus 4x minus 2 pi x plus pi x over 4 has to equal to 0. Alright, so we could just multiply everybody by 4 at this point, and that would get rid of this and this. So 32 minus 4x minus 2 pi x pi x equals to 0. Okay, awesome. Because I'm sure you have a horrified face right now, but we're going to keep going here. We got this. All right, let's combine this guy with this guy. So 32 minus 4x minus pi x equals to 0. All right, we're making progress now. Let's get the x terms by themselves. So I'm moving them to the right. Okay, now I'm going to factor out the x. I'm going to divide this off. I'm just going to change the order. I don't like the order it's in. It doesn't matter what order it's in, but I sort of want the pi in the front. It's my brain likes that better. Okay, so I took out the common factor of x, I divided it off, and I just fiddled with where everybody was sitting. Alright, since that's the where the critical number equals to 0, that is actually the value for x. So this is the x value that will make the Normandy window have a maximum area, believe it or not. And so now all we have to do is find y. So y again equals to 32 minus 2x minus pi x over 4. And yes, you're going to shove that horrific looking number for x in there, because we're out here having some fun. And x in again. For this x, you put that in again. Okay, so my suggestion to you at this point would be to multiply up down by this pi over 4 just to collapse the complex fraction. That's what I would say. So sort of like distribute that in to like each term so that the fraction collapses. I'll try to add a couple extra steps if that's a little too hard to see. So I'll multiply this by pi plus 4. In this one, the pi plus 4 and the pi plus 4 cancel, so you're just left with this times this. Same thing here, the pi plus 4 cancel, so you're just left with that all over 4. Oh, we're getting so close now. You got to distribute this 32 in. Okay, today 32 times 4 is going to be 128. See if I can fit it. This and this go. This is going to be, that's half actually. And divide by 4. 16. Oh, I lost something. You guys are probably thinking, damn, she lost something. I lost this bottom. This bottom has to go. This guy here goes with this. Okay, so we're going to end up getting 16 over pi plus 4 for the y. Okay, so we got our x and our y. And units would be good. Feet. This guy's in feet and feet. Okay, my friends. There we are. Homework problem number 21 complete. That is the dimensions of x and y for the Normandy window. Okay, gang. Have fun with these problems. I'll catch you again later on in the week. Bye-bye.